dear students, how are you? مع درس جديد. Now chapter 4 about volumetric analysis والمعروف باسم titration. ما بعرف ليه في ناس مجرد ما تسمع كلمة titration بتخاف وبتقول الدرس كتير صعب. هنلاحظ مع بعض درس titration خاصة لما نحل أسئلة عليه very simple. خلينا نفهم بس المين concept اللي له. Volumetric titration in redox reactions. Volumetric titration consists of the addition of a determined volume of titrating solution with known concentration C1 to an exact volume of solution with unknown concentration C2 to be determined. يعني المين aim للتايتريشن هي to determine unknown concentration. عادة بتكون بالبيكر حنسميها later analyte. فإذا by a certain method we can calculate it. Volumetric titration is based on a reaction which occurs between titrating solution titrant and the solution to be titrated which is the analyte. يا جماعة التايتريشن إذا بدي ألخصها بكل بساطة. If we add solution A over solution B، إذا حطينا solution over solution بشكل عام in a random way، هيدي البروسيس بنسميها mixing. فإذا أنا عم بعمل randomly mixing بشكل عشوائي، عم زيد مادة فوق مادة. ولكن شو الفرق بينه وبين التايتريشن؟ التايتريشن we add يعني a certain volume of the titrant اللي بتكون موجودة فوق we add it to the beaker. فلما أقول أنا we add a certain volume يعني في كمية محددة مش زي الميكسينج in a random way. هيدي الفرق البسيط بيناتهم بخلينا نقول عنها volumetric analysis or what we call titration. من خلال specific volume صار فيني أعمل calculation للconcentration اللي بتاعت السوليوشن in the beaker. For example, titration of ferrous sulfate with potassium permanganate solution. Let's give E node للMnO4 minus Mn2 plus هي 1.71 volt. E node للFe3 plus Fe2 plus equal 0.77 volt. هيدي setup of titration زي ما ملاحظين. We have a stand with a clamp, a magnetic stirrer. We have a beaker. We put in it ferrous sulfate ونسميه بشكل عام الانالايت. We put in the burette. Here the burette. We put KMnO4 solution وبشكل عام نسميه titrant. And we put in the beaker volumetric and we put in the beaker magnetic bar. فإذا magnetic bar لنعمل stirring. Balance the following equation مثل ما تعلمنا بالدرس الماضي in acidic medium. Fe2 plus will give Fe3 plus, so we add 1 electron. MnO4 minus will give Mn2 plus, so 1 Mn 1 Mn. We add here 4 water to balance oxygen. 4 times 2 8, so plus 8 H plus 5 electrons لأنه هون 8 plus minus 1 7 plus 2 plus, so 7 minus 2 5 electrons. We multiply equation 1 by 5 ليصيروا equal number of electrons, so 5 5 and 5 electrons. The second equation بنزلها زي ما هي. 5 electrons with 5 electrons will be cancelled, so the overall equation will be 5 Fe2 plus MnO4 minus plus 8 H plus. It will give 5 Fe3 plus Mn2 plus 4 water. Now, what about the calculation? At equivalence point. What is meant by equivalence point? The equivalence point is the point where both reactants, in this case Fe2 plus and MnO4 minus reacts completely. تفاعلوا 100% reacts stoichiometrically. So, at equivalence point N للpermanganate over 1 equal N للFe2 plus over 5. وليتر حنزيد هون in the beaker هون in V equivalence added from burette. So instead of number of mole we put C times V of the permanganate equal C times V للFe2 plus. عادة 3 known 1 unknown. يعني for example C, V and V given, C unknown, cross multiply you can find the value of C.
This is our dilutions of hydrogen peroxide, which is 20 vol. What we've done is we've made them all up to 30 millilitres. So in this one we've got 10 millilitres of hydrogen peroxide, 15, 20, 25, 30, and then we've made up the difference with water. To each of the conical flasks, add 20 millilitres of the mixed solution. We're now going to add our dilutions of hydrogen peroxide. Add 10 centimetres cubed of 1 mole of sulfuric acid. At the same time, start the stopwatch. What you're going to see is they'll change colour at different times depending on the concentration. So the more concentrated solutions should change faster.
Kinetic study on the reaction between iodide ions and hydrogen peroxide. The dependence of the reactant concentration on the rate of a chemical reaction can be studied from the reaction between iodide ions and sodium thiosulfate in the presence of hydrogen peroxide. Hydrogen peroxide is an oxidizing agent that oxidizes iodide ions to iodine in an acidic medium. The reaction is monitored by adding a known volume of sodium thiosulfate solution and starch solution to the reaction mixture. The liberated iodine reacts with sodium thiosulfate and reduces to iodide ions. When thiosulfate ions are completely consumed, the liberated iodine reacts with starch solution and gives a blue color. Our aim here is to study the reaction rate of reaction of iodide ions with hydrogen peroxide at different concentrations of iodide ions. Materials required: 0.1 molar potassium iodide solution, 0.05 molar sodium thiosulfate solution, distilled water, 2.5 molar sulfuric acid, starch solution, 3% hydrogen peroxide solution, conical flasks, measuring cylinders, glass rod, and stopwatch. Procedure: take 4 250 milliliters conical flasks labeled A, B, C and D. Measure 5 milliliters of 0.1 molar potassium iodide solution in a measuring cylinder and transfer it into the flask A. Similarly, add 10 milliliters of potassium iodide solution to flask B, 15 milliliters to flask C and 20 milliliters to flask D respectively using the measuring cylinder. Using another measuring cylinder, add 10 milliliters of 2.5 molar sulfuric acid to the flasks A, B, C and D. Now, using a measuring cylinder, add 85 milliliters of distilled water to flask A, 80 milliliters to flask B, 75 milliliters to flask C, and 70 milliliters to flask D to make the volume of solution 100 milliliters in each flask. Add 5 milliliters of starch solution to the flasks A, B, C and D using a measuring cylinder. Add 10 milliliters of 0.05 molar sodium thiosulfate solution to the flasks A, B, C and D using another measuring cylinder. Now, measure 5 milliliters of 3% hydrogen peroxide solution in a measuring cylinder and add it into flask A and start the stopwatch immediately. Stir the mixture using a glass rod and watch for the blue color to appear. Stop the stopwatch when the blue color just appears and note down the time required for the appearance of blue color. Repeat the experiment by adding 5 milliliters of 3% hydrogen peroxide solution to flasks B, C and D, and note the time required in each case for the blue color to just start appearing.
What about now the characteristics of the titration reaction? But first, let's define the equivalence point. What is meant by equivalence point? It's the point at which the two reactants react in stoichiometric proportions. فإذا هي البوينت لما يتفاعل التو reactants 100% reacts completely. The characteristics of the titration reaction: it should be complete, it's unique, it's fast and spontaneous. مثل ما تعلمنا بالدرس الماضي دلتا E should be greater than or equal to 0.3 volt. Fast أكيد هي سريعة. complete سهم واحد. The reactants give only products. unique معناتها ممنوع بنفس الوقت يصير إلا التايتريشن رياكشن. مش مسموح أي side reaction تصير على جنب. فإذا عشان هيك بنقول عنها it's unique reaction. What about the procedure of titration? First, by means of a volumetric pipette طبعا بنحدد الكاباسيتي. take 20 milliliter of ferrous sulfate solution, put them in a flask, conical flask or Erlenmeyer flask. Fill the burette with potassium permanganate solution. Add the potassium permanganate solution until a color changes is observed in the flask. بنضلنا بنزيد لغاية ما اللون يتغير. Record the volume V of the solution added. بنعين الفوليوم اللي وصل لإله. وبهالطريقة بنكون كتبنا التايتريشن reaction in a very simple way.